Hello, my name is TD Lane, and today we are talking about relative dating. To start with, we will be talking about what relative dating is and the basic principles of it. Relative dating is the process by which rocks are dated without knowing the specific age of them. This can be applied to rocks and geologic events and is extremely useful for when absolute dating methods are not applicable. Relative dating has 6 principles behind it we will need to go over before we can getting into examples. Superposition, the layers at the bottom of undisturbed strata are older than those above. Original horizontality, sediments deposited from above were originally deposited horizontally. Lateral continuity, within a depositional basin, strata are continuous until they thin out at the edge of that basin. Cross-cutting relationships, deformations such as folds, faults, and intrusions are younger than the rock they cut across. Inclusions, when rock formations contain pieces of another rock, that included rock is older than the host rock. Fossil succession, assemblage of fossils, are unique to the time they lived and can be used to correlate rocks of the same age across a wide geographic distribution. Now that we are done reading out the textbook, we can get into examples of relative dating. For the first example, let's look at a depiction of a fictional formation. Starting from the top, we find recent aeolian deposits on top of the brown strata, which in reference to superposition would mean the aeolian deposits are younger. Continuing, we find that the brown strata contains the same blue fossils as the yellow strata, which, following the principle of fossil succession, would indicate that they are close in age, with the yellow strata being older due to the principle of superposition. Next, let's look at the light green strata and dark yellow strata, neither of which contain fossils. These are underneath the yellow strata and are thus older, with the dark yellow being the older of the two. Following these, we have an igneous stratum dividing the dark yellow and pink strata. There is a nonconformity between the dark yellow and igneous strata, which we will be talking about in depth later. The pink strata contain yellow fossils not found in any of the above strata, which would suggest that these are unique to the time at which the pink strata was formed. At the bottom, we find the tan strata, which contains no fossils. To the right of this diagram, we find that the strata are geologically the same as those on the left, but do not contain fossils and are not in the same position as those on the left. Here we observe an event known as a fault, where the strata have been moved from their original position. Using the principle of cross-cutting relationships, we can ascertain that the fault had to have happened after all of these strata were formed. Conveniently, this fault did minimal deformation, which allows us to quite easily correlate the rock. As we can see, the strata to the right are the same as those to the left, with the brown strata having gone through considerable erosion. Next, we see another example of a cross-cutting relationship with an igneous dike going through the brown, yellow, green, and dark yellow strata. This dike would be younger than all the strata under cross-cutting, as we previously discussed. That finishes up this example, from which we will move on to unconformities. Unconformities represent periods of non-deposition or erosion. These are found rather commonly throughout stratigraphic columns. The unconformity you are most familiar with is likely the one in the Grand Canyon between the Vishnu basement rocks in both the Grand Canyon supergroup and the newer Paleozoic rocks. Often ignored, though, by pseudoscience, is a second unconformity here between the supergroup and Paleozoic rocks. Moving forward, there are 3 types of unconformities. Nonconformity, which occur when a sedimentary rock is deposited on top of igneous and metamorphic rock. Disconformity, which occurs when either non-deposition or erosion took place. Angular unconformity, which occurred due to tectonic disruption to the original horizontality of the strata, which then erode and have new strata deposited on top. Now let's close the textbook and get to work. Starting off, we have the brown strata, which overlies an igneous lava flow. As such, we know that this is a nonconformity. Underneath this is the light gray and orange strata, the latter of which has noticeable erosion at its border with the light gray strata. Thus, this is a disconformity. Further down, we find a series of tilted strata, representing an angular unconformity. It can be difficult to ascertain which of these is the oldest, but fortunately the light gray strata possesses a dike in it, which doesn't extend through the rest of the strata. From this we can infer that the light orange, green, and yellow strata are in fact younger than the gray strata, while all these are still older than the strata deposited on top of them. As we have finished that example, let's move on to a real-world example, the low to mid Ordovician Ogwen group, to apply these methods. As the rock formations are in Welsh, and I don't speak Welsh, I'm going to use abbreviations given by the paper Stratigraphical Framework for the Ordovician of Snowdonia and the Leyland Peninsula. Link in the description. We will be ignoring the left side of this diagram to ease our life. To begin, we have the NOG formation, mudstones and slates, which is on top of the CSW formation, mudstone and siltstone, and has part of the GEL formation, calcareous, volcaniclastic sandstone, and tuffites passing into it. The GEL formation overlies the CSW in its lower constituent, ash, while passing laterally into the NOG with the CY limestone member. This could indicate a disruption in the overarching depositional environment of the NOG and underlying CSW. Moving on to the CSW itself, we find it sitting on top of several tuffs in mudstone, along with having intermittent tuffs and the GYG siltstone's member. It's relatively easy to ascertain that it is older than the above NOG and younger than the lower AF tuff, CGU tuff, and TYG mudstone. The intermittent tuffs and siltstones would have been deposited at a similar time as the rest of the formation, although we can ascertain the order in which these were laid. Starting with the Gwyn being the oldest, then the GYG siltstones being laid after, and the FRON being laid last, while the CSW continues afterwards. Looking below, we find large-scale deformation and faulting with numerous unconformities. Going from above, we have the AF and CGU tuffs overlying the BGL, PNF, PGV, CF tuffs, the TYG mudstone, the SERW, and the ALL sandstone. While this is littered with unconformities, we can ascertain that the AF and CGU are the youngest components, with the PNF coming afterwards, followed by the CF, then the BGL, SERW, and the PGV. After these come the BRT, MU, and OF. I still haven't gone to everything in the right, have I? As I think I've demonstrated enough, volcanism makes everything harder. We should move on to unconformities, lest we be here for the rest of the day saying abbreviations. To start us off, we can see a notable angular unconformity between TYG and the underlying strata. Following this is a disconformity that can be seen between ALL and DYN. The Robel volcanic group is a notable nonconformity with the surrounding strata. Well, isn't that a bingo? While I could go on about the unconformity between the LGV and the TYG, or the one at the bottom of the bend log, this has gone on for long enough. The goal of this video was to give an overview of concepts in geology for those who were not as well versed in it. While I may have achieved that with most of this video, I am rather certain the real-world example gave a grand view into how complex geology can be. It certainly taught me how little I know of Welsh. Thanks to the following people for inspiring me: RJ Downard, Jackson Wheat, Dapper Dino, Gutsick Gibbon, Corporal Anon, Aaron Ra, Steve McRae, Pelosia, Conspiracy Cats, Stephen Bauman, The Late Psystrike, The Late Bill Ludlow, and finally, Kent Hovind and every other pseudoscientist for inspiring me.